So today we're going to start looking at parallelograms.
Oh, I bet.
So first of all, everybody knows what a parallelogram looks like, but the definition is that a parallelogram is a quadrilateral, means it has to have four sides, with two pairs of parallel sides. So here in this figure, since we're given that both pair of opposite sides are parallel, it's got to be a parallelogram. That's the definition of a parallelogram. Now, we're going to look at some properties of parallelograms, and most of them are pretty easy to see, I think. So for example, the first property is that the opposite sides are congruent. If you have a parallelogram, the opposite sides are going to be congruent to one another. And I think that one's pretty easy to see. It looks like that, right? It looks like AD and BC are the same length, and AB and DC are the same length. So that's one of the properties of a parallelogram. If this is a parallelogram, then the opposite sides are going to be congruent to one another. It's also true that the opposite angles are congruent. So if this is a parallelogram, angle J and angle L are the same size, and angle M and angle K are the same size. That's always going to be true in a parallelogram. And again, I think you can just look at it and go, yeah, it looks like that. It looks like those angles are the same size. One that's not quite as obvious is this next one, and that is that the consecutive angles are supplementary. When we say consecutive, that just means one right after the other. So like if I go from R and I move around counterclockwise to S, those two angles are supplementary. Or if I start at T and I go clockwise to S, T and S are supplementary. It's not hard to understand why if you remember something from first semester. What kind of angles are angle V and angle R? Pardon?
Same side.
Same side what?
Interior.
Yeah, same side interior angles. Sorry, I just couldn't hear it. I'm going to get her a megaphone. Yeah, those are same side interior angles. And remember, when the lines are parallel, the same side interior angles are going to be supplementary. And the nice thing about this unit is you don't have to worry about which ones are parallel. Both sets of them are going to be parallel. Unlike when we did parallel lines earlier, usually it was only one and you had to be really careful as to which one. Here you don't have to be. And then the fourth property is that the diagonals bisect each other. So if you draw in from A to C and D to B, those cut each other in half. So AM is congruent to MC, and DM is congruent to MB. Be careful of this note down here. This does not mean that the two diagonals are congruent to each other. Everybody look at the picture for a second. Which diagonal is longer, AC or DB? Which one do you think is going to be longer?
DB.
I've got two votes for DB and one for AC so far. I got two each. Now it's 3-2 DB. All right. Think about it this way. Don't worry about drawing this, but everybody look up here, please. Let's say you start with a rectangle. And like this is a box or something. And you've got string from one corner to the other. If I push on this box over here on this side so that it leans, See how this corner got further away from that corner? That's the long diagonal, because this is the direction that the parallelogram leans at the top. This diagonal actually gets shorter, right? And if you eventually folded the box all the way up, or close to it, you can see how these keep getting closer and closer to each other while you fold that up, and these get further and further away from each other. So rarely in a parallelogram will the diagonals be congruent. In fact, as in an ordinary parallelogram, they will never be congruent. Later on, we'll study some of the special parallelograms. It turns out in a rectangle, that's true. They are congruent, but in ordinary parallelograms, they are not. All right, so let's do some problems. This first one is really short. Shouldn't take you very long at all. Find the measure of each angle of parallelogram COLD, which I thought was appropriate for today. Do it. Talk to your shoulder partner if you want to, but find those other three angles. I'm going to be calling on someone randomly in just a moment, so don't let your shoulder partner, who's not behind you, your shoulder partner is beside you, don't let your shoulder partner be wrong. Peter, your shoulder partner is Kevin. That's who you should be talking to. Garrett, your shoulder partner is Angel. That's who you should be talking to. This is not a difficult concept, gentlemen. Put them away, please. Gerson, since your shoulder partner's not here today, feel free to talk to the gentleman behind you. All right, since there's lots of conversation, that means there's plenty of time. All right, shh. So let's see, desk 6, that must be Peter. What's angle D?
112.
112? How did you get that?
That's a good question, but so
Shh.
like, same side interior angles, what's the word? They added to 180.
Yeah, they add to 180. They're supplementary is the word you were looking for. Good. All right, who's in desk 15? Give me angle L.
I'm gonna be honest, I didn't get to that part yet, but I had.
What did you get to?
I got to 112, where that was as far as I got.
Okay. Geo, what's angle L? Okay, why does your shoulder partner know?
I wasn't with you.
You got to take care of your shoulder partner.
He was talking about
Well, she is better looking. I get that. But
So,
you got to talk to your shoulder partner. Take care of your shoulder partner. Okay, Geo, how do you know that this is 68? There's two different ways. Tell me one of them. Shh. Yep, the opposite angles in a parallelogram are congruent. And then number 2, Blake. Yeah, there are several different ways you could tell me why that's 112. Tell me one of them. Yeah. These two are supplementary, or those two are supplementary. Or, what else could he have said, anyone? Yeah, the opposite angles are congruent. All right, good. Let's move on. right, so we're looking for the length of xy. Okay, we know that the opposite sides in a parallelogram are the same length. So since the length of WZ is 12a, this is also 12a, but that's not completely helpful because we don't know what a is. However, we also know that WX and ZY are equal to each other. So we can go, okay, 6a plus 10 is equal to 8a minus 4. Carson. We'll subtract 6a from both sides. We'll add 4 to both sides. Divide and we get a is 7. So then xy is 12 times 7, which is 84. All right, then they ask us for angle y. Well, angle y is going to be the same size as angle w. So it's going to be 18b minus 11. But again, that's not particularly helpful. But, and I'll take a volunteer for this, someone tell me, what do we know about angle w and angle e? They're supplementary. That's exactly right. Thank you, sir. So then that means that 18b minus 11 plus 9b plus 2 should be equal to 180. Grouping the like terms, we have 27b minus 9 is equal to 180. Add 9 to both sides, and we get the 27b is equal to 189. Let's see, 27 and 27 is 54. 54 and 54 is 108. I can't do that all in my head. It's bound to go 7 times. Yep. So B is 7. So the measure of angle Y will be 18 times 7 minus 11. See, it's 126 minus 11. 115. Did I do all the arithmetic right? Somebody check me. Okay. I don't always trust my arithmetic. All right. Page 3 then. So they tell us that we have a parallelogram. If we don't know that we have a parallelogram, you can't do any of these. So I'm going to write in all the stuff that they gave me. LM is 28 inches. I'll put that on the diagram. There's no good way to write that LN is 26 inches on here, so I'm just going to write it over here. LN equals 26 inches. Peter, I thought I told you to put those away. Put the headphones away so that they're not distracting you in any way, please, sir. Thank you. The length of LK is 20 inches. The measure of angle LKN is 74. LKN. I think the easiest thing to do on those is to just write it outside instead of writing it inside because it gets pretty messy. And then MNO, that's this angle, is 62 degrees. So if this side is 28 inches, then how long is NK? 28 inches. And let's stick with sides for just a second. If this is 20, what else do we know? MN is also 20. What we don't know yet is how long is LO? Well, if this whole thing is 26, remember that the diagonals in a parallelogram cut each other in half. So then each one of these is 13 inches. All right, now let's look at the angles. Angle NML. NML. Oh, that's the whole angle at M. So what's that going to be, Gabby? Yeah, it's going to be 74. Because it's the same as the opposite angle. And then ONK. ONK. This angle. It's easy to get stuck at this point. But remember, if we didn't have the diagonals, it might be easier to see it. But if this angle is 74, how can we find this whole angle at N? What's the relationship here? I've asked it, this will be the third time I've asked. Pardon? So they are supplementary, exactly right. So we'll take 180 minus 74. This whole angle is 106. 62 is part of that angle. So if I subtract 106 minus 62, I get that the other part is 44 degrees. Hey, any questions about that? All right, your assignment is in the book.